This presentation on critical cooling for data centers, evaluating different approaches, is brought to you by dpAir. Critical cooling for data centers is designed to maintain specific humidity and temperature levels within climate-sensitive environments. If proper levels aren't maintained, equipment could fail and the data center would experience costly downtime. However, a proper cooling system will allow data centers to operate efficiently. When IT equipment is running, it generates heat. And in a closed data center, this heat needs an outlet or it can build up and cause equipment damage. Critical cooling for data centers is therefore needed to remove the heat from the facility. Several approaches exist for heat removal. Some of the more common methods include air cooling, liquid cooling, and free cooling. Using air for critical cooling for data centers provides definite benefits. Ubiquitous air doesn't damage IT equipment. It's easy to move and allows warm air to rise and separate from colder air. Computer room conditioners, or C-racks, remove heat to the outside. Converting warm air to colder air, C-racks can cool an entire data center room, row, or server rack. Critical cooling for data centers commonly use a raised floor approach. C-rack supplies cool air underneath the floor. Fans draw the cool air up to reduce temperatures around servers and other IT equipment. As the waste heat from server rises, the C-rack collects it, cools it, and returns it beneath the floor. In many instances, liquid cooling provides more targeted temperature control. For example, chilled water can be delivered directly to where it's needed, like a server rack or cabinet. This approach may be more efficient since an entire room may not need to be cooled. Liquid cooling works especially well in high-density applications. However, significant downsides do exist. First, accidental water leaks pose a serious threat to IT equipment. Second, condensation can build up the transport infrastructure and also affect sensitive equipment. In addition, liquid cooling is generally more expensive than air cooling systems. Free cooling reduces the amount of infrastructure needed in critical cooling for data centers. For example, running chillers and compressors associated with the traditional methods discussed above is minimized. At its most basic level, free cooling can refer to bringing in cooler outside air to cool data center equipment. This technique can be as simple as opening windows. However, to use this method of critical cooling for data centers, companies have to be cautious of contaminants entering the facility from the outside. They also need to be concerned with humidity variations. Fortunately, many alternatives of this approach have been developed to deal with the issues. Sophisticated designs use heat wheels or exchangers to transfer heat outside. This practice eliminates contamination risks from drawing outside air in. In addition, evaporation techniques can cool liquid without needing chillers. So what's the best approach? Critical cooling for data centers depends on several factors, including your facility size, power density, budget, and more. If budgets are limited, air cooling might be the best option. On the other hand, very high-density environments might require the more costly liquid cooling to keep things running smoothly and adequately protect IT equipment from the excess heat. Several variations exist between air and liquid cooling solutions. Finally, an industry group recently increased allowable temperatures for data center facilities. As a result of this increase, free cooling will expand in critical cooling for data centers. When managers can operate their facilities at higher temperatures, they can consume less energy on cooling. They can also leverage cooler months during the year for free cooling their data center.